Okay, we're continuing on with the sine law. And so we're looking at, basically these are questions where we have to use the sine law and we don't have a diagram. If you have a diagram, then it's a little bit different and you'll see why. But ambiguous, think about what that word means. It means you're not quite sure from the information what something is. It's ambiguous. So in terms of this is always with the sine law, where we have the ambiguous case. And it means that we could have two angles, okay, when we solve for an angle in the sine law. So it's always to do with angles, and it means there might be two different ones. So two possible answers. Okay, so first, when we solve the sine law for an angle, we end up with sine of an angle equals some number. It's a ratio. Often it's already in our calculator. In this case, it's given to us what that ratio is. And so when we are finding an angle, we have to do the inverse operation. So it looks in our calculator like sine with a -1. It's not an exponent. It means inverse of sine. Okay, so then you get your calculator out and you go second key, sine key, 0.8333. Okay, always check, should remind you that it's in degree mode, so mode key, make sure it's in degrees, and that's your angle. So I'm going to go to, it doesn't say 1 decimal place. Okay, so theta is 56.4. So that's great, except there's really more than one angle, and this will actually make a little bit more sense once we've talked about angles in a circle. But for right now, I'm just going to quickly, if I were to draw a side 56 to make a triangle this way, actually it would be more, give me a sec, it'd be more like this, okay, and that should be a straight line. Okay, so this would be 56.4, okay, degrees in your 90-degree triangle. So that's great. The thing is, if I were to do an angle and show, so basically take that line that I've just drawn and do a reflection in the y-axis and draw a triangle there, okay. This triangle, although it doesn't look quite the same, I'll maybe try to fix it a little bit. I'm using my mouse again, so. Okay, that triangle there is exactly the same as the one on the right. So this angle in here is 56.4, but we consider the angle from this positive x-axis to this one to be an angle that gives you the same ratio. So that we call a standard position angle, and you'll talk about that in a couple of days. And so, well, when we have a straight line and we subtract 56.4, what is that angle that I've drawn with the arrow there? Well, that would be 180, because that's a straight angle, minus 56.4. Okay, and so this, if you get your calculator out, that angle's already in there. Go 180 minus that answer, and you get 123.6. So that is another possible angle for a triangle. So that what that means is If you are not given the diagram, like you can obviously tell the difference between those two angles. If it looks like it's an acute angle, you would keep this. If it looks like an obtuse angle, you would use this. If you're not given a diagram, then you could have both. So it's ambiguous which one it is, and you would have to solve both triangles. Okay, so always when you're using the sine law, calculating an angle has no, ambiguous case has nothing to do with calculating a side. Always with an angle and only with sine law. Okay, then you have to consider both. So we're going to go through all the possible types of questions here. So you'll see, again, a triangle isn't really given. This information is given, and we've started to draw a triangle but haven't finished it. So there's a horizontal line, there's angle 30. So C is going to be somewhere over here. We know that, so if I draw like side like this, then A would be 10, and this would be C here. Okay, so just use pencil for right now because we'll fix it up if this doesn't look like what it's supposed to. So if we're trying to find angle C, okay, then we need a matchup, right? So that matches up, and we need this. So we're looking for an angle. So sine of C over 20 equals sine of 30 over 10. So sine of C equals 20 sine 30 over 10. I'm writing a little bit too big, but in any case, so we'll go 20 sine of 30 divided by 10. Okay, and we get 1. Well, that's interesting. Okay, so now when you do, to solve for C, you go second sine of that ratio, that answer, and you get 90 degrees. Okay, so C is 90 degrees. All right, so this is actually a 90-degree triangle. So what I want to do here is just fix up my diagram a little bit. And C is 90, so straight line here, and it's 90 degrees. Only one choice, okay? If we went 180 minus 90, we'd get 90. So, so sometimes you don't know what a triangle is. Maybe it's 90, maybe it's not. So in this case, it turned out that it's a 90-degree triangle. Take a look at the sides. So you're given, always given an angle and two sides when you're solving for another angle. And if you take a look here, the angle that you're looking for is opposite along the longer of the two sides. Okay, so just keep that in the back of your head. Okay, next one. Now we're opposite in 8. Well, because we've already done the last one, and this angle is the same and 20 is the same, you probably will figure out there's no answer to this, because think about the closest distance from a point to a line is at 90 degrees, right? If I were to go to the right here, it would be longer. To the left here, it'd be longer. 8 is shorter than that. So we're really only going to get to like there, all right? And so there's no triangle. Okay, so no triangle exists. Let's see what happens if you didn't realize that, because maybe you didn't do a diagram. So notice how it's basically the same here. So I'm just going to go to my step for solving, because it's going to be sine C. We're given the exact same information or sides and angles, but different measurements. So this is going to be 20, but sine 30, but it's going to be over 8. So now when I go to my calculator here, you can actually even go up and copy that if you have a newer calculator and just delete on the 10 and put 8. Okay, so you get sine C equals 1.25. Remember, we've talked about this. If you get sine equaling a number that's greater than 1, it's not possible. It doesn't exist, because that would be like saying the ratio is has a hypotenuse that's shorter than the longest side. So you can try second sine, second answer, and it says error. If you go to, it'll flash on where that number was. Okay, the answer doesn't like it. It's too big. All right, so let's get out of that. So here, so C does not exist. Okay, so there's no triangle there. Again, notice that the side that you were trying to find, okay, or the angle you were trying to find is opposite the longest side. Okay, so we had an answer of 90, no answer. Let's see what happens here. So now 12, so think about it, 12 is longer than 10. So it could be something like this, or it could be something like this. Okay, so that could be C or that could be C. So this is going to be the ambiguous case, two possible values. And you may not know that right away. We just know that based on our previous two examples. You don't want to have to go through that all the time. But if we then, so again, we've got the same A and C. The only thing that's different is, sorry, capital A and C. The only thing that's different is your side A. So I'm just going to change the 8 from the last one to a 12. And again, so get out your calculator. See if you can go up here. If you want to copy it out, oh, actually, I'm just going to redo it because I just copied it in the wrong place anyway. So sine of, oops, 20 sine 30, close the brackets, divide by 12. So sine C equals, now it's a number less than 1, it's 0.83 repeating, and so C, the inverse sine of that, okay, don't round it or anything, use your unrounded in your calculator, so second sine of that answer, and that's 56.4. So kind of rings a bell from the previous, okay, that one there. Notice how it was 0.8333, so we did round it. We got 56.4, and when we did this one, we said there were two possible angles. So same thing here. So it's going to be that, and then 123.6. So these will basically, these will add to 180. Then take a look at your diagram, which one's which. So this one here would be the one that's bigger than 90. So actually I'm going to do that in red. So 123.6. If we had this diagram here, this would be the one that is less than 90. Okay, so two possible triangles given that information. again, the side opposite C is bigger than the side given. Okay, so you're only going to get the ambiguous case if that's true. If you take a look at the next one, it's, I'm going to go back to my blue. Same angle, same side here, but A is 25. Well, notice this side here is 20. So my 25 can't go in that sort of same direction. It's for sure going to have to go out this way and be longer, right? So this would be 25. Okay, so my C would be here. So there's only one case in this one. So again, my sine of C will equal 20 sine of 30 over 25. If you want to copy it out, or you can re-enter it. So that, and then I'm going to go back and just copy over the 12 with a 25. Okay, we get a value less than 1. So C equals, and then second sine of that answer is 23.6. Okay, and that's 23.6. Okay, some things that I do is I don't necessarily memorize what's in the chart that we're going to talk about. I think about, does it make sense in a calculator? So for example, say I did, okay, 180, I'm just going to do this in green because it's not really going to be an answer. So let's say I did in my calculator 180 minus 23.6. I get 156.4. Okay, that does give you the same sign, but looking at my calculator, if I had an angle of 156.4 and 30, that already is 186.4, and I still haven't got the third angle. So there's no possible way you could have another angle there. Okay, so that's sort of what you do unless you want to memorize what's in the chart. So let's take a look at it. It says the ambiguous case may occur when using the sine law to determine an unknown angle. So that you have to know. If the unknown angle is opposite the smaller of the two known sides, there's only one solution. So that's like the last one that we just did. So that was like D. Okay, so I'm just going to put D there. If the unknown angle is opposite the larger of the two known sides, so that's like A, B, and C, it will have one solution if sine of theta equals 1. So that was like question A, and theta there was 90 degrees. Okay. No solution if sine of theta was greater than 1, so that was like B. And two solutions if sine is between 0 and 1, so that was like C. If there are two solutions, the two angles are supplementary. If you remember back to junior high, that means they add to 180. That is the, oh yeah, sorry, it's right there. They add to 180. Okay, so let's do some practice. So here, again, we don't know our angles. We don't know the triangles, I should say. So here, if I've got this side here, and I want to draw an angle of 110, then it's got to be bigger than 90, right? Something like that. Okay, and so I'll join this up here. So this would be my angle R. And then you decide what you want, P or Q. So I'm going to do P here and Q here. Okay. And so actually maybe I'll switch them around just because we were doing a known angle at the bottom before. Okay, so I'll do P here and and Q here. All right, so R is 110. Okay, little r is 16, little p is 10. Okay, so then you're looking for angle P, okay, and it's opposite the smaller side, okay. So what did that tell you in the last one? If it was in the chart there, if it's opposite the smaller, there's just one solution. But in any case, you can just do your sine law. So sine of P over 10 equals sine of 110 over 16. If you want to go straight to your sine of P ratio, you can. Okay, so 10 sine of 110 divided by 16 is 0.587. And again, you're keeping it in your calculator and using the unrounded. So second sine, second answer, and that's 35. Basically, and it doesn't say what to round to, that rounds, even if we went to one decimal place, to 36. So let's just go to the nearest whole number for now. So 36. If we were to try to do, I'm just going to switch to green here, and then if I go 180 minus that angle, I'd get 144. Okay, but if I try to put 144 in there plus 110, I'm way over 180. So even if you didn't remember that it's going to be just one angle, you can figure it out that it's just going to be one angle. Okay. Next one here. So now I always start with the horizontal. My angle of 70, go from there. So I don't know, looks something like that. Okay. So this would be R, and that's 70. Okay, that would be 11. I'm going to put P up here just because the shape of my triangle. This looks to be a little longer. Okay, and that'll be Q. So then I am finding sine of P over 15 equals sine of 70 over 11. So now my angle is that I'm looking for is bigger than the other one. Sorry, the angle that I'm looking for is opposite the bigger side than the other one. So that means maybe I could have ambiguous case, or I could have no possible angle, or I could have one. So basically a few possibilities. Okay, so now I can't really see it. Can you do that? Okay, so we're going to go 15 sine 70. This up for you. Sine 70, close the brackets, divide by 11. And I get a number that's bigger than 1. 1.281. So I can stop right there. Your calculator is going to give you an error if you try to find an angle. So therefore, no solution. Okay, so this actually is not possible. Can't even draw it. Okay, so so that's that case. My horizontal there, and my R is 40. So kind of like like that. So my r would be 12, which would be across from it. And so I'll join this up like this. So this would be my r, and it's 40. Okay, this would be 12. I'll make this p this time. Doesn't really matter which one. If I do that p, then this would be 14 over here. No matter what, I'm trying to find angle p. Okay, so sine of p equals, sine of p over 14 equals sine of 40 over 12. Oops, I gotta fit in the 14 there, sorry. Okay, get out your calculator. So 14 sine 40 divided by 12 is 0.7, let's go to 4 decimal places, 0.7499. You keep it in your calculator anyway. So now P is inverse sine, because the angle we're looking for is opposite the longer of the two sides given, then we have a choice. Could be, well, not a choice, but it could be one of three things. No solution like the last one, one solution which is 90, or two solutions. So basically you can tell it's not going to be the no solution, because that is less than 1. It's not going to be the one solution of 90, because it's not equal to 1. And now, so if we go second sine of that answer, we get 48.6. We'll go to 1 decimal place for this one. So 48.6. So P equals 48.6. And so again, I want to subtract that from 180. So go 180 minus 48.6. Oh, actually, I could have done 180 minus that answer. Sorry, that's a little bit more accurate. Now in this case, it's only calculating one thing, so you get the same. 131.4. Okay, now the diagram that I chose, the 48.6 makes sense, but what it could also look like would be here, here, extending out further, okay, and then back this way, okay. So this would be your R, your P, your Q, okay, and so this diagram, so here, this one goes for this diagram, and this one goes for this diagram, okay. So you might not draw both diagrams right away, because you don't know yet, if you don't consider the sides. Okay, and then D here. So D, again, we want to take horizontal. Okay, now it's 30, so it's less than the last one. Okay, and then R is 7, P is 14. So let's join that up like that. And we'll go here. So this is R, and that's 30. And that's 7. P is here, this is 14. So sine of P over 14 equals sine of 30 over 7. Oh, sorry. Sine of P equals 14 sine of 30 over 7. And in our calculator, so what was that? That's 14 sine 30 over 7. So 14 sine 30 divided by 7, okay, is 1. So when you get 1, then remember you know it's 90 degrees. So this is equal to 1. So that means you don't even have to show the work. You know that P will be 90. So in this case, I would have to change my diagram. Actually, I'll go like this. So I can move this to 90, and I can shorten this. Okay, and move this a little bit over. Okay, so then this is 90. Okay. Okay. Then last one, brand new question, so no relationship to the other ones. And so again, I'm going to draw a side there, an angle of 40. Okay. So this is going to be 40. You can label it A and 40. You know that your little a will be 12 and your B will be 14. So you decide if you want to label that 12. I would maybe, I'm going to extend mine a little bit here. Okay, so now then I want to join this up. Okay, so I'm going to call, so this is 12, and I'm going to call this B. So this is 14, and that's C. And it says solve for the triangle. So you can solve for angle B or C first, right? Because you have to get both of them. You have two sides, and so you have a matchup here. So for sure you do have to use the sine law. And so it'll be, I'll start with sine B over sine B over 14 equals sine 40 over 12. Okay, and so doing this, we're going to have, I'm just going to clear, we're going to have 14 sine 40 divided by 12, so 0.7499. Well, sounds familiar from the last question, similar question. Okay, so, oh yeah. This is C continued. That's why it looks familiar. So if you look back up at C, we got 48.6. Okay, but let's pretend, because I'm a little slow this morning. So we got 48.C from that work in our calculator. Okay, and then could it be possible to have another one? So we'll go 180 minus that. And, oh, what did I just do? Oh yeah, I did second sign. So I want to go 180 minus, I think I still have it there, that angle. Okay, and that is 131.4. Okay, and if I check that, that would still work, right? So 48.6, so if I put this in here, 48.6, then, so here, then angle C will be 180 minus 40 minus 48.6. Okay, and so you can do that 180 minus 40 minus 48.6. You can just do that. You don't need to go back to the unrounded because it's just one angle, so that's 91.4. So that's basically sort of what our diagram looks like. Or you could have C equals 180 minus 40 minus 131.4. So 180 minus 40 minus that 131.4, and that is 8.6. So it's a really tiny angle, but it does exist. If you ended up getting a negative, then you know it doesn't exist. So I tend to always just calculate the two possible angles and then see if the triangle works. In terms of what that triangle would look like, so here we have our 40, but now our B is really, it's big, right? So it'd be maybe going like that and like this. Excuse me. And so here, this would be your 40. This would be your 131.4. And this would be your 8.6. Okay. I guess in a smaller scale, because I kind of extended that out. Okay, so that's the sine law. As I said, you don't have to memorize that that chart, all the different cases, if you don't want to. If you calculate what the two possible angles are for each sine when you're calculating, this only is for the sine law when you're calculating an angle. If you find both, see if it makes sense in your triangle, then go for it. If your triangle is already drawn for you, then you choose which one it makes sense for. Okay, so that's the sine law.